Right, good afternoon. Mimosa, you may not have heard of us before. We're fairly new kids on the block on the wireless side. We've been going about 4 years as a startup. We're a Californian company, and we're, as it says there, real big wireless. I'm Keith Newton. I'm the sales engineer for EMEA region. And what we do is a whole range of backhaul and access products, primarily for wireless ISPs. So there are other uses as well, but our focus is to wireless ISPs, and you'll see that there's some significant advantages why we produced what we have and where we're going in the future. So some of the radios are on there. We have backhaul radios, access radios, client radios, and then we have a cloud management software as well. So this is really our total architecture of what we do. It's fiber speeds. We're really trying to get highest performance wireless connectivity that you can. Fiber-like speeds at Wi-Fi costs. So this isn't going to cost the earth. This is low-cost equipment, but at the very high end of technology. So as you can see, we're from the fiber connection or the egress to the internet. We've got a point-to-point radio. We do a number of different backhauls. That's just one scenario there. If you can get fiber all the way to your access point, even better. In fact, some of our biggest customers in the world are actually fiber operators, not wanting to dig up the last mile, not wanting to do the last 500 meters. Whatever it is, fiber to the home is extremely expensive, and obviously it's going to be great if you can do that, but if you can't, wireless is the most, today is the best option because of the speeds that we can now get. So the product you can see there, which is the one I'm going to focus on today, is this little radio here, which is an access point. It's a point-to-multipoint radio. And we produced that, and it's absolutely unique in the marketplace. And as you can see, it's point-to-multipoint, and we're connecting to 3 CPE devices. And we have a number of CPE devices as well. There's most of our products are on display at the back of the room. So you can see the CPEs on the houses, on the homes, or on the buildings, whatever. And we can be providing them over 500 megabits per second to those clients. We also do the device that's in the home, and that's really important. We didn't really set out to be an indoor Wi-Fi company, but ISPs particularly are sitting here, back here somewhere, taking the money off the people in the homes over here, and their problems are nearly always in the home. So what you can do, because we manage every single unit, the back-to-back, point-to-point, the access, the point-to-multipoint CPs, and the gateway or Wi-Fi access point in the home, you can manage all of that and see all of that on your cloud. So wireless ISPs have set up all over the world, mainly to go after the rural areas, because the fibre partners weren't there and DSL was too far to get good connectivity. So a great area to start, and we're certainly there as well. So we use our products in the rural area. But what we really wanted to do was go into the suburban and the urban areas. And there may be DSL and fibre operators in here, but certainly in many countries in the world we're finding that ISPs can actually compete in this area, because putting our access points up in this area isn't expensive, and they can offer as good a connection as the fibre and DSL operators, even in the urban and suburban areas. And we have specific products, which I'm going to show you today, targeted at both the suburban and the urban areas. But let's not forget the rural, because that's where most of the wireless ISPs started. So these are the products. The A5C on the left-hand side there is traditional the way wireless ISPs have worked in the past. You find a tower, a nice high point, and you connect your connection to that backhaul radio or fibre to that tower, and then you put a sector antenna on your radio, and you transmit as far as you can in the 65 degree or 100 degree or whatever the connection is. And that's all good, and that's the way to do it for rural and low density areas, and we do that as well. The only thing that we do is all our radios are the latest 802.11ac, so they're the latest 802.11 standard. They're also big MIMO, so they're 4x4 MIMO today, and we're already working on 8x8 and going further on that, and you'll see the connection speeds you can get from that. These are well over 1.5 gigabits per second radios, actual rates to the customers. The smaller unit on the side here is the A5, and we have two versions of that. And this is really a unique product in the marketplace. It was really designed for the suburban and the urban areas, but anywhere that you've got connectivity to maybe 20 or so homes within a small area. We call it the micropop solution. So we're typically in about a 1 kilometre radius. Can be smaller, can be a bit bigger, but of that sort of order. It's not going out 5-10 kilometres from a mast. For that, you use the A5C on the left. So just a little bit about the technology of what we're using. MIMO is obviously what we're using. Mimosa, the whole name came from MIMO, multiple input, multiple output, and that gives us the massive capacity. Today it's 4x4, next year, or very soon, it will be 8x8, and it will continue. The technology is just moving on. So it's massive capacity, hundreds of megabits. We're also using TDMA, time division multiple access. That's the best way to get spectral efficiency. If you use standard CSMA, which is what your Wi-Fi chipsets are doing for internal Wi-Fi and your iPhones and smartphones, etc., it's not the best solution for outdoor. This we can get much higher spectral efficiency, and it's all, for the wireless ISPs in the audience, it's all about spectral efficiency. Taking everything back to a tower, you're all struggling with connectivity because you've run out of bandwidth, you've run out of channels. Your neighbours are transmitting at higher levels, and they're using poor antennas that are spectrally inefficient, and they're throwing out radiation all over. So we're trying to stop that. The other thing we do is synchronize, so we can spectrum reuse. So if you find in your area that you've got a 40 megs of channel, and that doesn't have to be contiguous, you can have 220s in different areas of the spectrum. But if you've got a good 40 meg channel in the area where you're trying to operate, you can reuse that channel. So with all the Mimosa radios in there, each radio has a GPS synchronization chip on top, and they will all synchronize and timestamp within 1 part per million. So it's absolutely within nanosecond, they're all actually transmitting or receiving at the same time, rather than what CSMA is doing is just transmitting, and if it doesn't get there, it'll retransmit it sometime later, which is fine for certain applications, for indoor, but not for what we're trying to do. We're trying to get fibre speed to the home. And finally, cloud. The cloud is an option you can use. It's free to use, so you buy our product, you buy the first 2 radios for back-to-back, and you can use the cloud. Very, very useful for monitoring the system, and you can see everything on that cloud, from the backhauls to the access to the client, and even the gateways in the home. You can monitor the whole lot. They're also SNMP compliant, so if you want to use your standard system that you're using at the moment, you can do that as well. You don't have to use the Mimosa cloud. So this is about MIMO. Many of you probably know about, originally a long time ago, SISO, single input, single output, provided about, 30 megabits per second. Then came along 2x2, 150 megs up to 450 megabits, 802.11n type scenarios here. Mimosa started, because we started recently, with 4x4 radios. So our radios are at least 1 gigabit per second capable. And you can see the 4x4 there, but we also support multi-user MIMO, which will allow 2 lots of 500 meg to 2 clients, for example, simultaneously. And the direction that Mimosa is going is, as you can see here, 8x8, which would give you multiple multi-user MIMO streams. So there's a lot going on, and we're a new company that's actually developed very quickly over the past 18 months or so. So what I wanted to concentrate on today, because I only have a few minutes, is our micropop, because it's a different architecture to what you've been used to in terms of the rural. And the A5 is the product that we're using here. So typically, as I said, the A5 is for around about a kilometre radius. Can be less, can be a little bit more, but it's around about a kilometre. And typically we want to mount that unit at an approximately the same height as the client devices. So on the building here. So it could be a 3-storey building, whereas actually we're feeding 2-storey building, but approximately the same height. This certainly does not go on a 60-metre tower or something like that. We want to get off the tower. We just want to backhaul to that tower one radio of 20 meg, 40 meg, 80 meg, whatever channel size you can have to get your internet connection into these areas. This is exactly the same as what the mobile operators are doing with LTE. It's all about small cell and getting near to the customers. So we've designed this little A5. Whoops, I didn't mean that. We designed the A5 to be small and to fit on someone's home. So you can come and have a look at this later. This is one with a glass top on it, but this is an A5 that would go on someone's home. And it's a Gigabit plus radio with GPS in there, and as you can see, it's not an Omni. It has 360-degree coverage, but it's done with 4 sectors. And we have some interesting technology in the way that we do that, and how we place 4 antennas so close together and get the performance that we do. So that's our A5, and as you can see, it gives us, in this example, 300 meters here, but it will give up to maybe a kilometer or so at the highest rate. So we were working at MCS 9, 8, 7, etc., but you can work at lower rates if that's the service you're giving to your customers. And then at the other end, we have the client devices, the C5, which is a low-cost radio with built-in antenna. Very simple, very easy to use, just pointed at the A5, and this will give you high performance. The A5 can have up to 100 C5s connected to it, so that's sort of a theoretical maximum, but typically ISPs are looking at about 50 to 60 connections per unit, so it's very cost effective when they start to do the maths. So we've done it by designing a quad sector, and customers, wireless ISPs, have done this in the past by buying 4 radios and 4 antennas and doing it and a switch and lots of other things. If you do that, even with the lowest cost equipment, you'll probably come out to be more than one of these, and it's not as pretty, and it's not going to probably go on someone's home, and it's not managed as well, and there's a lot more places that it's potentially going to error. So it's a quad sector, not an Omni, and it's still a 4x4 radio, 4 streams. The client devices will take the best 2 streams and use those 2 streams, so it does all that automatically. Another interesting feature of all our products is that we have a 2.4 gig radio built in. So there's a 2.4 in this unit, also in our backhaul radios. And that's not as an access point, that's as a management tool. So if you're lining one of these up, then you can use your smartphone. You just log into it on, there's an SSID and a password just for you that you can get into, and you could connect this up and aim it and check the RSSI. So the engineer who's doing the install can do this very quickly and very easily without even a laptop, just with a smartphone. Also, if they needed to go out to site later on because they think there's a problem with someone's house, maybe the antennas have been blown offline or whatever, they don't have to necessarily go up there and check it out. They can do it all within, 40, 50 meters or so, with a range of the 2.4 gig Wi-Fi to the iPhone. So it really checks it out for ease of use. So this is just the C5. I've got one at the back of the room if anyone wants to come and have a look. It's 20 dBi antenna, 500 megabits, IP55 rated for outdoor use. The specs are there. So let's just have a quick look at the A5C. So this is the same radio that's in here, except it's now got 4 N-type antenna ports on the bottom of it, as you can see there, and it goes into a special 4x4 antenna. There's a couple of these on the market at the moment. This particular one's from KP Performance, but there are other manufacturers as well which we've tested out. So the A5C is the connectorized version, still 4x4, but it's for more longer range rural type scenarios. So it's rugged again. These are all IP67 rated, extended temperature range, etc. It's designed for worldwide use, so hottest countries, coldest countries, wettest countries, etc. And the other feature that we have built into these A5s is antenna beamforming. So you may have come across that term before, but it's now become a reality. And what beamforming does for you is that and it's particularly useful for fixed clients rather than clients that are wandering around a home or whatever. It sort of works for that, but it works a lot better for this, because the clients, as the clients in our case, are houses or buildings, they're not moving. So when the A5 sees the unit, it can actually formulate a beam in the direction of the client, and it does this by it gives it an extra 3 dBs, which is effectively a doubling in range. But what it actually means in most cases is it gives you a better signal-to-noise ratio, it gives you a better RSSI, and it therefore gives you a better throughput. So it's a huge advantage. Directional beams also reduce the noise, so the better the antenna and the better the beam, the narrower it is, it's not receiving noise from other sources. And finally, it also enables the multi-user MIMO, so it can do 2 at once. That's the point of this. So it's transmitting twice to 2 different clients simultaneously, or receiving. Talked about sector sync. Mimosa is all about synchronization, reuse of channels, and getting the best out of the frequency, out of the channels. And sector sync, what that allows you to do is actually use 2 of our A5Cs back to back. So you can use exactly the same channel on both of these and they won't interfere. So spectrum's the key asset that you have. You've got a 40 meg channel or whatever it is, then you want to be careful with that. You can actually go back to back with these and just use 1 channel. This is just the KP Performance antenna, a little bit closer look here, and the bracket that comes with it, actually the Mimosa A5C fits directly on the bracket of the KP antenna. If you wanted high performance and high density, you can go all the way around a tower with A5Cs. So this is using 65-degree antennas, and you can reuse the spectrum 3 times here. So the 2 A's is 1 channel, 2 B's is the next channel, and the 2 C's is the 3rd channel. So you can reuse the channel, but I need 3 channels to do 360 degrees. But this is huge capacity to thousands, hundreds of users at this stage. One final development of that is that KP Performance actually are the only ones in the world at the moment making this, but they make a ×8 antenna. So there's 8 antennas built into there for an 8x8 MIMO, or 2 4x4s, which is what we're doing. So we've put 2 A5Cs on the back of here. They'll have to be on separate channels, so they will have to be spaced apart. But they go directly into that 65-degree antenna. Taking that one step further, if you wanted full 360-degree coverage, then using 6 of them, you can give you 360-degree coverage. We now need 6 separate channels, so you can see A1, A2 are back-to-back, B1, B2, C1, C2, etc. So this potentially gives you, you'd have to get a 5 effect to this, but this would give you about 12 gigabits of throughput to your clients from over here. At 50 clients per access point, that's over 600 clients attached, or 1,200 if you're going for the full 100 on there. So it's huge capacity, capable. We're also about to launch a product called the C5C, which is, the C5 is the client operating at 5 gig, and the little C means it's connectorized. So this will allow you to use a different antenna, like the ones from RF Elements, I think it's Performance, RF Elements there. So you can use a different antenna to give you the capability, the range, etc. that you want from the client if you're not using the C5 directly. So again, high performance and high throughput. And finally, the product I wanted to just talk to about, because we've just launched, is this little unit here. It's called the G2, and it's the indoor Wi-Fi product. So this will go inside in the house, and it has a PoE 802.3 AT. This powers the C5 on the outside, so the installer will just plug this into a relevant socket in the customer's house, take the PoE output and power the C5 on the roof or wherever it is on the side of the building. This then gives as an access point, it's pre-configured with a user and a guest access for the home. They have to do nothing, you have to do nothing, and the big advantage is it's managed from your cloud. So you can see this unit on the cloud, as you can see all the Mimosa products, and that means if the customer rings up saying, oh, your broadband's not very good today, I can't get on, or I'm getting less than a meg or something, your support line can say, well, they can look at all the way down to this unit and see his iPhone or his laptop connected, his RSSI with the MAC address, so you know which one it is, and say, oh, well, you're at minus 95, he's probably in the room upstairs or somewhere way out of the house, getting a poor performance. So you'd ask him to move into the room where this little unit is, do the test again, and that would test that your network is perfectly okay. What it really means is his house is too big or the walls are too thick for a single access point to penetrate the whole house. But you can send him or sell him another one of these. They only have to be connected together for 2 minutes with an Ethernet cable and a button press, and the slave will learn all the information from the master. He can then plug this somewhere else in the house and it will mesh together. So they'll mesh on the 2.4. It's not power line, which a lot of people think it is. It's not. It is Wi-Fi 2.4 gig mesh. So that will double his coverage area, double his throughput, and then you can test again. And you can have a third one connected, but the third one needs to be wired. So you can put 3 in a home, one meshed and one wired. As I say, we've got all the products at the back here. If you haven't come across Mimosa before, please come and have a chat with me, and thank you for your attention.